So for our next talk, we have Nicholas Blum and a team. I'll let you introduce the rest of the team from UNC Asheville.
So Nicholas Blum, we've got Henderson and Morrow.
Yeah, good afternoon everyone, thanks for coming. We're here to discuss building a board game using the Unity 3D engine with using a ModelView controller type architecture. So in this presentation we'll be discussing how the game works and the game that it was originally built off of. We'll be discussing the tools we use, some of the programming styles that we use, the structure of the project, including the art assets, the team development processes and such, as well as a demo and some of the future work we'll be planning for future semesters. So maybe some of you heard of the game. It's called King of Tokyo. This is what we based it off of. It's a board game. It's sort of like a King of the Hill style game where Tokyo is sort of the hill, and every player is a monster, and you win by either defeating all the other monsters or obtaining enough victory points, as they're called. And then that'll win you the game. And the game state can be affected by cards in the game, which you can purchase with currency and stuff. And this will apply many different effects or completely alter maybe the state of the game. Rolling the dice in the game, there's 6 dice, will give you energy, which is the currency in the game to buy cards and such, victory points to possibly win, health, and as well as dealing damage to opponents. So this is a brief just diagram of how rolling the dice works in the game. So you have 6 dice. Each face has, health, energy, attack, or points, which can earn you victory points. You're allowed to re-roll up to 3 times, and you're allowed to choose which dice you want to keep. So you can keep a couple dice, re-roll, or re-roll the whole set if you want to. And this is just an activity diagram which illustrates how the user is prompted if they want to roll again, roll a number of dice, which ones they want to keep. And once they reach the maximum amount of rolls, the dice will lock, and then the effects will be applied, which means if you had rolled health, your player will be healed. If you rolled attack dice, it will immediately attack the player that you're attacking and whatnot. And then it checks for conditions if you won the game, perhaps by winning enough points or defeating the other monsters. So, this is you.
So the engine we use to develop our game is Unity. I'm sure some of you all have heard of it. It's a great engine. It's really popular for game design, and it uses component-based game design, which is pretty useful. What that means is, for example, we have monster characters that represent the players. They're 3D models. They're made up of several subcomponents. When the players die, we want to search them for cool animations. So what we do is we explode the player components into tiny pieces and scatter them across the board. You'll see that in a second. Now, we want those components to take care of themselves afterwards. We can't just leave them lying around the board. It clutters up the game, and it would just slow everything down. We could keep track of them in an array, and then over time just remove them, but actually, because of Unity, we just attach a timed removal script to the components, and they take care of themselves. It's a multi-platform game engine. We can develop this for PC, Android, PlayStation, Xbox, what have you. And it's pretty simple to port things over to the other platforms and build for them. We can develop using C#, a strongly typed robust language, and there's a huge community for prospective developers, YouTube tutorials, example games, and plenty of answered questions for people who are trying to develop games. So we used a lot of the architecture and methods of object-oriented programming. We have discrete elements, dice, players, cards, game boards, etc. They're responsible for their own states, and they communicate through interfaces. We have to make sure that at any time the player who's playing the game can see an accurate representation of the game itself. So we utilize the message passing between elements. And another thing that we use is the mediator design pattern. So our HUD, which basically shows the player what's happening in the game, has tons of separate components. It'd be really clunky to try to update each of those components individually. So what we do is we package up a data structure when the turn ends or the turn begins, send it to the HUD, and the HUD handles actually populating the different elements inside of it. And of course, as the project continues to get larger and larger, we want to keep it scalable, we want to keep it reusable so that we can add more and more cards and methods to the game. We developed this using ModelView Controller Architecture, or MVC. I'm sure some of you guys have heard of that as well. And it's really cool because that means that one of us can work on the model or the logic of the game, one of us can work on how the game looks, and the other person can work on communicating between them. Why implement it? Well, as I said before, it allows for independent development. If we ever wanted to port this to a different game engine, we could just take the logic code, write the new view in the new game engine, and have it communicate with the new controller. And the logic code is abstracted from the graphics code, which means that if somebody's working on the logic, they can write the method, for example, to roll the dice. And the person working on the view can write the method for the player to click on the roll dice button, and they'll communicate together without having to worry about the other person's work. Unity itself doesn't really implement MVC, but this is actually kind of useful, which means we can write our model or logic using object-oriented programming. We can write our view using component-based programming, and our controller makes them both work together seamlessly. Here's our class diagram. I'm not going to go through it too much, but basically we have our logic over here. We have our view from this side, and our controller communicates between them. And there's two interfaces we use to communicate between them. When the player using the view tells the controller they want to do something, the controller sends the message to the game state using iGameState, and then queries using iGameState for the resulting state of the game, and then repopulates the view. At other times, for example, when the player dies, we want to let them know immediately, so the game state will send a message using the iGameState events receiver, telling the controller to update the view immediately. And back to Henry.
Thanks. So this is a UML sequence diagram illustrating all the sequences that the game has to go through once a turn has ended. There are a lot of conditions that must be checked with events triggering with cards in order to ensure that everything happens in the right order and everything doesn't cause bugs or break the game. So the controller will evaluate on the end of a turn attack dice, whether or not the player is attacking. The game state will return an object containing who's being attacked, the amount of damage being done, etc. The attack then initiates, and then it checks if the player attacked is in Tokyo. Because if you're in Tokyo and you're attacked, you are prompted whether or not you want to leave or stay in Tokyo. This sort of king of the hill concept is, if you are in Tokyo, you have the ability to damage all other players on your turn. However, you're vulnerable to all other attacks by players outside of the hill or Tokyo. So they're prompted whether or not they want to stay or leave. And this will trigger on-yield Tokyo events, which I'll talk about in a moment. Once that, we loop through the players, generating new on-hit events, also more events I'll talk about momentarily, mitigating possible damage from card effects and whatnot, and that is eventually returned, and we'll break out of the loop, and we'll check for if any deaths occurred from the players by looping through the players and checking their health, and triggering on death events as well. And then the game will basically check for game over conditions and perform a couple cleanups before the player's next turn begins. So, I just mentioned events and effects. So what is that? As our game began getting more complex, when we started programming in cards to the game, we knew that there were certain conditions that would have to be checked before certain actions would happen. For example, if a player died, we needed to be sure to know that before they were able to use a card on them, for example. So every player has what's called a card effect manager, and this will store passive effects that they may have been granted through cards. So one card is called Evasive Maneuvers, and that is an on-yield Tokyo event card. So if you choose to leave Tokyo, it will not receive any damage from you leaving. If you stay, you'll take damage. And this is sort of an effect that is stored on the player that the game knows about on events being triggered such as that. They're added to the players using sort of a first in, last out order, which is illustrated here. Once an event is triggered, such as a new on-hit event, it'll enter their event stack. And if in the same process a second event is added, the pointer to current event will point to event B, which is just an illustration of the Philo sort of order. And then here's another example of a card, Spiked Shield. When you receive damage, the player that attacked you suffers one. This is just an illustration of another on-hit passive effect that you would have on your player. Briefly talking about the team development process. So we worked in a team on this. There's several other members besides just us, and we utilized version control software in order to do this. This was incredibly essential because we needed to make sure that our code base was all up to date and we were aware of what was going on. So we utilized GitHub for that, and this also helped us with being able to branch certain features out if we were developing really large experimental ones, and being able to merge them back into the current code base at a later time, as well as issue tracking for bugs and just generally keeping in communication. And we also used C# sort of Visual Studio tag styling documentation, which really helped for new members of the project being able to understand what had gone on previously, as well as future members understanding the code base in the future.
Alright, so for our models we used in the game, they were created in 3ds Max, which is a software program developed by Autodesk, one of many that they make available for free to students. It's a personal favorite of mine. It's very easy to use, and it's got quite a lot of features. But what this helped do is help me create these models out of many different pieces, and we followed a styling of kind of a smooth, stylized, out of a stylized perspective to make sure that things weren't too overly realistic, and it kept them simple with polygon counts. to help keep the game running smoothly, quickly, and efficiently. Here's one of the models. You may notice a certain resemblance to Close Encounters of the Third Kind, if you like that. We got the Squishling guy there. Not talk about him. And then in our UI interface art, we've had 4 different instances of it. We've got our initial one, which you'll see up here in the top left, which was used mainly to make sure everything was working properly. We weren't worried about, oh, does this look nice? It was just, hey, does this work? Then we all spent time together drawing a mock-up on whiteboards and using group discussion, and we finally made up this beautiful piece of work. This was done by another one of our group, Michael Kazkuda, and he uses Adobe Illustrator because it uses vector graphics, which means it's very quick and it also keeps things so they scale quite well. They don't get blurry when you change their sizes. And now we'll have a demo done by Mr. Blum.
Suspense.
Let me try plugging this back in. Is this going to be putting out to the screen? Okay, good.
Just hit this
All
right.
right, folks, that's right. I'm going to try not to bump anything here. We'll just happen. All right, so we got our main menu. It's pretty bare bones. Let's go right through that. So you can go ahead and add players. We're going to use some random names to go fast. You can pick your alien or monster or whatnot. You can randomize them if you want. I'm going to go ahead and pick the ones that we've actually worked on so that you can see those in their glory. And we'll click start. There we go. Alright, so for the purposes of this demo, I've given all of the characters really low health and a little extra money to start with so that you can see some of the cards in action. So here we go. You'll notice in the UI that if you hover over one of your opponents, you'll see their information in the upper right corner of the screen. You can also click on them if you want to see their cards. When you click on them, if they had any cards, they populate here. Once you're done looking at what they have, you can return to yourself. You've got your victory points over here, you've got your energy over here, and you've got cards to buy here. So I'm going to go ahead and buy Spiked Shield, which means that if somebody attacks me, they'll get some damage. Hit that. And now we're going to try to go into Tokyo. So I'm going to roll the dice. Notice here that you can choose to keep some dice if you like. I'm going to keep those dice, roll again. And now we're going to go ahead and hit end roll. It applies the health. We'll hit end turn, and because I'm attacking, it'll move me into Tokyo. There we go. So now I'm in Tokyo, I've got 4 health. And the question is, can I survive until it's my turn again and do damage to everybody? If I can, I'll probably win. If I can't, well, poor Henry's just not going to make it. Alright, so here we go. Adam's going in. What card's going to get? Anything good? Not really. Oh, extra turn. Can I buy that? I can, yes. So now we have an extra turn. Instantaneous effect card immediately applied. I'll get 2 turns. Let's see if I can go ahead and take Henry out right now. Alright, so let's roll the dice. I got 1 damage. That's pretty good. Roll again. Alright. 2 damage. 3 damage, ending turn. Notice here that you have the option to leave Tokyo if you'd like, but we're going to go ahead and stay because we think we can make it. Alright, 1 health. Alright. Oh, it's just 6, unfortunately. Alright, folks, I think Henry's unfortunately not going to make it. Let's end the turn. He can try to escape, but no, it's not going to happen. He explodes. The pieces take care of themselves, as I talked about earlier. I'll go ahead and do 1 more turn. I want to use this cool Flame Strike card. It's Michael's turn. He's got money to buy this. Flame Strike does 4 damage to everybody else. Let's go ahead and use it. You can play it. You can try to leave. I don't think it matters. Looks like he's won.
Alright, now our future... Stop pushing buttons.
It's my computer, not me, I promise.
Okay, so our future work includes a few things. First of all, aesthetic-wise, we plan to more in detail texture and animate our monsters. We'd like to design some better models for the city. You may have noticed right now they're just some prisms, some cubular, rectangular, square prisms that are quite boring. Then we'd like to stylize the terrain and add in some sound effects. Game design, right now our main focus is to continue making cards and making sure they're balanced properly for the game. And in the future, we'd like to add some ways to track player stats in between games, implement a network multiplayer, maybe get some AI working in the game, and get a save load feature. Are there any questions?
Thank you.
Yes?
Are there any differences between the monsters other than graphics?
No.
Not at the moment, but that's something to think about in the future.
Yeah.
Okay.
Yes?
I noticed in your future work you wanted to implement a network where you could have a multiplayer. Right now, is it just alternating between whose turn it is?
Yeah, right now everybody would have to be using the same system, just
It's
kind
a
of
hot seat
trading.
player.
Okay, I just wasn't sure. I could.
Yeah.
Since this is a little research on like ModelView controller software, what were the advantages that you saw using the tools that you use in comparison to other methods out there currently and stuff like that, or other things that you've researched?
That's a good question. When we started this project we started this project a few semesters ago, and I came on last semester, and we actually started trying to import it into Unity. And when we started out, we just wanted to do traditional object-oriented programming. We just wanted to have everything inside of one script for everything. So we realized really quickly that it became very hard to control because we had to maintain not only the logic, but how it looked. So if we changed like the logic, we also had to change the view at the same time, and it got really hard to maintain. So that's why we decided to go with MVC, because we realized, hey, Unity is component-based. Let's let it do what it does best, do the view. And we know how to do object-oriented programming in C#. Let's make the logic using that, connect them with the controller, and we're done.
Okay. Cool. Thank you.
I would like to know if you have measured the overhead of using MVC with objects that get repeated a lot, get multiple instances in the game. I don't know if you have that, if the components or the monsters are a single object, but sometimes with MVC we get the object instances are not so easily to change in a batch way, like if all the states were stored in a matrix or something. You guys measure some performance difference between object, ModelView controller system, or a more low-level matrix comparison?
Well, are you talking about, like, for example, when we have like a set of monster scripts, like controlling them with like an array or something like that, versus having them be their own thing?
Yeah, because I don't think you're creating changing the physics, alright? You're leaving all to the engine.
Yes.
Okay. Yeah, because I was thinking about physics on object-oriented designs kind of get messy when you have multiple instances in different places of the memory, so you can't optimize some operations. But in your case, you're just using object-oriented for the logic of the game, right? Okay.
That's a good question. We haven't measured it. We only really have 6 monsters, so I mean, the overhead is going to be minimal. It might be good for cards at some point to measure that in the future. That's a good question.
Does your model and view and controller run as different processes? Or do they run as the same process and pass data in the form of native objects of C#? Or do you have some kind of way to pass data between the two entities?
So like with this, you mean?
Yeah, so like where you've got your data passing between your controller and your model back end, are those two different? Is this left-hand side a completely different process that's running?
They're both the same process. We do actually implement multi-process. Unity has a type of multi-threading that we use for like the end turn, We have to wait for the player in Tokyo to make their decision, but for the general purpose of the game, it's all one process. The controller generates the game state when the game starts, and then they start communicating between each other after that. And the view is Unity, so basically they connect to the controller once the game starts.
But they do that all within a single process?
That's correct.
Okay. So in order to make this distributed, or you'll have to break that out, right?
Yes, which is a cool idea for sure.
All right, let's thank our speakers once again.